Hey guys, welcome to my fourth and final video on the series of SQL for data science using SQLite, Pandas, Seaborn, and Jupyter to query sets of 10 million records or more. If you haven't checked my other videos, please go check them out. That's how we construct the database. And in this one, we're going to actually be creating a lot of plots and a lot of analysis out of that data set. As always, thanks for watching. If you like, click and subscribe. And I am really sorry there is a little bit of a noise. I think my mic got entangled with my hoodie and it kept on making a noise that I didn't notice until now. Anyway, I'm sorry for the noise, but I hope you guys find this video useful. Thank you. We'll start by creating a new notebook. Let's call it 04 Intro to SQL. Let's get started. First, import SQLite 3 in Pandas. And let's open the database. SQLite 3.connect citibike.db. Now, remember last time we created this helper function we call Q that allows us to execute some SQL safely without killing our machine. To do that, we can use Pandas read SQL query with a parameter called chunk size. So first we pass the SQL, the database, and chunk size is equal to 100,000. That's like a good number. So this will allow us to read the whole database, which is about 9 million records, produce some statistics and aggregates on that, and then as long as those aggregates or statistics are less than 100,000, we can easily analyze the data. Let's test it out. If we do res equals q select count asterisk from trip data and we print the res, this should give us about 8 million records. And here it is. The result is about 8,695,000 records. But those records have many outliers and data that is not properly cleaned. So the next step is to clean that data. To do that, we're going to create a new table that is going to have all these filters that we devised in our previous videos, and we're going to call it trip data clean. Let's do it. To do that, we just do db.execute. That allows us to execute an arbitrary SQL statement. In this case, this statement is going to be create table. We're going to call this table trip data clean as, and here we can use subselect or subquery to generate that table. We're going to have first 2018 minus the birth year as age, comma. Also we're going to have the gender. Case when gender equals 0, then we're going to say we don't know. When gender equals 1, then male. And when gender equals 2, then female. And as sex. And finally, all the rest of fields that we had before. From trip data, where age is bigger than 0, and age is less than 80, and trip duration is less than a couple of hours. Now we execute this. I just removed the parents and that worked. Okay, when this returns, that means that this succeeded, and to test it, we can just write a query. In this case will be select count asterisk from trip data clean oh, I missed it here. And when this completes, so here we have it, we can see how many records did we delete. We have about 87% of the records, which means we clean up about 37. We clean about 13%. Okay, let's get started. So to start doing analysis, first we select PyLab inline to load up all the plotting, and we do import seaborn. Now we start with our first query. We say cube res equals cube, the typical select age count asterisk as C from trip data clean group by age. So here we get the age and the count. Because we're grouping by age, we get the count by each one of the age groups, and we can use a histogram, hist res.age, the weights equal res.count, and the bins is the length of the res. And here it is. It shows us, it's a histogram of the ages for our data set. We see that most of the people is between 25 and 40, but we have long tails, we have long tails, a lot of young people, and a lot of older people. This is an interesting peak, close to 50. You can tell that if you were to decompose this, you'll have 1, 2, and 3, and maybe 4 different distributions composing this one that are being added up here. Another example will be res equals q, select age, let's do it this way, age some case when sex equals female, then on end as female, some case when sex equals male, then one end as male, from trip data clean. When you're writing long statements, sometimes it's easier if you separate each one of the pieces of the statement. Let's see what happens. Oh, this guy here. So here we're calculating the age, and for each age, we're counting how many females and how many males are in that age. And grouping by age first, here in this case is age. That allows us to, if we see the data set, goes ahead, we have age, how many females, how many males, and we will have one line per age. So now we can plot that. To do that, let's make a figure, make it vertical, fixed size equals something like 5 and 12. Then bar age, res.age, res.f divided by res.f.sum. So we're normalizing it. Color equals red, for example, for females. Label equals female. Then we can have a similar one. Trace.age. The difference is negative. The difference is trace m because m.sum, color, for example, blue, and a male. We have title, age distribution, y label, age in years, grid, and label. Let's see if this works. It's not called label, it's called legend. Yeah, there you have it. So age distribution by years, this is just probabilities, and you can see that the females are younger than the males in average. The distribution is for males has this interesting peak, so most of the 48, 49, 50-year-olders are males, but the distribution for females is heavily weighted towards the younger ones. So you can see that younger females tend to. And you can see that the typical population of citibike users in the female range is younger than the males. Very interesting. Now let's continue. Let's do a new one. Res equals q. Select age some case when user type equals subscriber, then 1 and as subscriber. Let's call it S, just faster typing. Some case when user type equals different from subscriber, then 1 and as D. From trip data clean group by 1. Press head. So in this case, we are doing a similar analysis that we did for females and males, but in this time, we're going to do it for subscriber or not subscriber. You can just go ahead and copy this guy and paste it here. And we just change whether it was female or male. We change for subscriber or daily. This is how it looks. For each age, we have how many subscriber or daily. So subscriber, daily, color, subscriber, daily, and we make the same plot, and here we have it. It's very interesting to see this peak. There's tons of males of 31 years that come to a city and have a daily pass. I wonder why. And you have a similar pattern. The male distribution is a little bit more homogeneous than the female. The female is very heavily weighted here. For the dailies, you have a similar pattern here, but it's backwards. The daily users are younger. The non-daily are more homogeneous, as you can tell by this distribution being weighted towards the younger age of the spectrum. Now, let's do a couple more plots. For example, let's see what is the duration. So the similar one as before. Res equals q. Select trip duration divided by 60 as duration sum the case when sex equals female, then one end as female, comma, some case when sex equals male, then one end as male, from trip data clean group by one. And that looks like this. And we use the same approach. This time we just like this for each duration. We get how many females and how many males. Obviously here we change age for duration, duration distribution. Duration is in seconds, and here res dot f m female male, and here is a plot. We see that, oh sorry, this duration is in minutes because we divided by 60 here. Minutes. This makes more sense. Most of the trips are very short, and I will say about 5 minutes. For this is the blue is male, the red is female. Actually, I don't like this. I'm gonna change the limits. I would like it to code around here, so ylim 060, and there you have it. Much better. Even 50 will be better. Most of the trips are around 5 minutes for male. For female are around like 6 minutes. So female, the average trip duration is longer, which is interesting. I will say that it is clearly noticeable in the data. All correct by age and by whether it's subscriber or not to get a better answer, but clearly here the average duration of females is slightly longer. Next, for example, here that could be a nice homework for the viewers. How does the distribution of durations varies for user types and genders? And ages. Okay, next. This is a nice little understanding of what is the population that uses. But we can also take a look at the different stations that are being used. So let's do res equals q, select start station name, comma, start station latitude as lat, yeah, start station longitude as long, count asterisk as c, from trip data clean group by 1, 2, and 3. In this case, we're just grouping by station, since the station is every time the station name will have the same latitude and longitude. These three are kind of the same, but allows us to do some nice queries easily. If we were to query this dataset a lot, we could store it in a temporary table. That will make our queries faster. While this is computing, let's get coding. First off, we can easily do the histogram like we showed before. Here it is. So station name, latitude, longitude, and count. So we can do a nice histogram of the latitude and the range. For example, last time we found the range of these latitudes and longitudes to be between latitudes between 40.6 and 40.9, for example. Range equals 40.6 and 40.9. Let's have 100 means. You can see that this is the latitudes, so it's north-south. You see a few different peaks that we will understand better when we see the plots in the like latitude versus longitude. But it's interesting to see. We can also do the same thing for longitudes. In this case, the ranges should vary. It should be from 74.1 to 73.8. Sometimes when there is this printing of stuff, I just put semicolon at the end, and that just cleans it up. Here you have it. It is very clear where all the stations are located. So let's start by doing a plot res.long, res.lat, and with a dot. There are some outliers, 0, 0. Those are not interesting. We really care about this little area here. So to do that, we just set the x-limbs. It's going to be between -80 and -70, and y-limb is around 40, so it's like 40 to 43. Let's see how it looks. Yeah, we're getting better. So here is like 74.74, 75, 74.5 to 73, 73.5. In this case, it's like 40.5 to 41. What they're getting there, you can kind of see Manhattan here. It will be 40.6 to 40.8 and a half, 40.8 and a half, and 74.2, even 0.1 to 73.8. And yeah, there it is. Now we have to make it proper. So to that, we just ask for a square picture. Fixed size equals 10, 10. And also, we define x start equals this number here. Y start is equals to this number. Start, y start, and then between these two, the difference is something like 0.3. X start plus 0.3, and between those two, the difference is something like 0.25. Y start plus 0.25. But since we want them to be equal, we just pick this to be equal. We call it extent equals, let's call it 0.25, for example. Extent and extent. The error is double dot here. Oh, there you go. You can clearly identify Manhattan here. If you're familiar with Manhattan geography, this is Manhattan, this is Brooklyn and Queens and Central Park, Battery Park. That's very interesting. We can change from this to a little bit bigger dots, for example, by adding an O here, and ms equals 10. 10 seems too much to me. Let's make it, actually, let's try to nail it better. 74.5 or 5 and 60. That's where we are. 63. Yeah, better. Now, between those two will be like 0.17. Too much. Let's get closer here. 645. 18. Yeah, much better. We can change this to be 10 or to be 8. So there's, yeah, this is nice. There's not so much overlap. So this is nice. And another thing you can do is play with the size. For example, let's copy this guy. We're gonna instead of doing a plot, we do scatter. It's res.long, res.lat, and then here the size is 35 times res.c, res.c dot max, and we're missing a comma. We don't need this actually anymore. Nice. So in this case, what we're doing is the count of times each one of the stations was used affects the size. So you can see there's very little usage here, but Midtown is very used. We can also play with the color. To do that, we do simply, let's copy paste. Here we can do cmap equals rainbow, and we add a color bar, which may distort it slightly a bit. What happened? You must first set red to mappable. Huh. Oh, we have to call this. See. Yep. And here it is. It's the same. Instead of having the instead of using the size as a marker, we use the color, which I think is easier to understand. So here we can see Lower East Side is very used. The West Village is very used. There's a pocket here which is very industrial node. It's very office spaces that not many people uses. And here there is less people because it's the Upper East and Upper West. You can also see, I believe this is Long Island City, and some pockets in Williamsburg and Greenpoint. So we can take this and just make it into functions, so we don't have to be changing the stuff. Let's call it def plot and web plot. No, let's call it matplot. X, Y, S, C, max size equals 50, and then here we change this for the max size, and this will be X, Y, and this will be the sizes and divided by the size max. Let's call it max size, just easier. This is the scale. Color equals color. There you go. Up. Now that we have this function, we use matplot res.long res.lat, res.c, res.c, and nice, yeah. Using both the size and the color, we can see there's this one dot here. It's very interesting. We can look at that later. It's very clear the distribution of how people uses the bikes in each one of the parts of the city. We can do a couple more easy ones. For example, let's do a query. Res equals q, select start station name, start station latitude slat start station longitude as long average trip duration as the sum case when sex equals female, then one end as female. We have the females, now the males. And then from trip data clean, group by 1, 2, and 3. That looks something like this. Res.head. We're grouping by station, and we're calculating the average trip duration and how many males and how many females. So we can do some plots. For example, my plot for res.long, res.lat, res.duration, 100 times res.the females divided by res.male plus res.female. So here it looks how you would expect. This is the station, this is average duration, how many males and how many females. And nice, here we have the color and the size. No, this is the size and this is the color. Size and color, yeah. This is the size and this is the color. So the bigger the size, the bigger the size, the more duration. So the durations are pretty similar. There's no big differences. You could, I think, changing the scale, you will see more details, but that doesn't tell you as much. What it tells you here is the female to male ratio. The redder, the more males, the bluer, the more females. Actually, no, you don't really have more females, but in most cases is how many males. And you can tell that for every station is mostly male dominated, but Midtown is pure males using the bikes. Here, more females. We can take this one and modify it again. Get the average, for example. Select the start station name, average. Don't need this anymore. Age. So we're calculating the average age for males and for females. And then we can do matplot, res.long, res.lat, res.f. We need the sizes, which is kind of annoying. So I'm just gonna get a multiply by 0 another one. All the sizes are equal. Res.f. Here it's telling you the ages. Bluer is very young. This spots very young people, and redder older people in their 40s in the upper side. Colombia has a mixture of peoples. It's very interesting. This is for females. You can do the same for males and compare them, for example. Males is very different. You can see the females, there are older female here, older female here. For male is very homogeneous. This area is very young, comparatively speaking, but other than that, it's very homogeneous. That's it. I think that you can keep on playing with these data sets, and you will get more information of how and when and who uses the data. Thank you so much, and don't forget to subscribe.